Hey everyone, welcome to the lecture for 2.1. So we're going to go over stem and leaf graphs, line graphs, and bar graphs. For line graphs and bar graphs, we're going to have a little Excel assignment where we take some data and we practice producing line graphs and bar graphs in Excel. So to start, let's begin looking at stem and leaf graphs. So a stem and leaf graph or stem plot is another way to express our data, organize our data. It kind of falls into that descriptive statistics realm. And it's only good really when the data set is small. So in order to create a plot or a stem plot, we have to, it's not necessary, but it's convenient at times to order the data. We also want to divide the data into kind of the second highest digit. So for us, we have 33, 42, 49, 49, 53, 55, 55, etc. So I'm looking at all the data here in this gray box. And so, for example, if we had 63, the 6 would be our stem, and the 3 would be our leaf. Just like as given in this example, if we had the number 432, 43 would be our leaf, and 2 would be our stem. So let's practice breaking these data into stem and leaf. So this is a score for the first exam in a pre-calculus class. They've already ordered it for us smallest to largest. And so basically what we're going to do is we're just going to go through. So we have for each number our stem. So notice that we're going up by tens, right? So we have these stems here, kind of underlining underneath each stem. In the stem, we don't write down multiples, right? So even though I'm seeing 9 appear a bunch of times, I'm only going to write 9 once. So I've got things in the 30s, 40s, 50s, 60s, 70s, 80s, 90s, and 100. So that's going to look like this. So 30s has stem 3. Things in the 40s have stem 4. Things in the 50s have stem 5. 60s have stem 6, and so on. And for the 100, that's going to be stem 10. So for the first group, we have things in the 30s, right? We only have one value or one datum in the 30s, and that's 33. So for us, this 3 and the 3, this represents the number 33. All right, so that takes care of our 30s. Let's move on to the 40s. So we've got 3 numbers in the 40s. So we've got 42. So look at this. This is 42. The 4 and the 2 together represent 42. And we've got 2 49s. So the 4 and the 9 together represent 49. And the other 49 comes from the second 9 here. So we're listing multiplicities in the leaf, but we're not listing multiplicities in the stem. This gives us an idea of the distribution in groups of 10. So right now, as I see it on my chart, I have one number in the 30s, which was 33, and I have 3 numbers in the 40s, and those were 42, 49, and 49. Whereas in the 30s, I just had that one number in the 30s, and it was 33. You do not need to relist your data here. In fact, you don't want to. The point is we're trying to break it apart and group it. I'm just writing those out to help illuminate where these are coming from. All right, so for the 50s, let's look at our 50s. So we've got a decent amount of 50s, another set of 3, 53, 55, and 56. So now I want to write 53. For the 53, I'm going to just put a 3. For the 55, the first one, I'm going to put a 5. And then for the second 55, I'll also put another 5. All right, and now on to the 60s. So I've got a 1, a 3, a 7, an 8, an 8, a 9, a 9. I'm going to write all those numbers out. 1, 3, 7, 8, 8, 9, 9, right? So the 6 is the stem for the 60, and then that single digit, that last digit at the end, those all get recorded, and you do write multiplicities. All right, so let's go on to the 70s. So again, here I've got a 2, a 3, a 4, and an 8. So I'll just write 2, 3, 4, 8. And in fact, from the stem and leaf, we can already see that 6 or the 60s has more data in that range than does the 70s or the 7, right? So it's already giving this idea of distribution a little bit. All right, so we need to move on to the 80s. So again, we're going to get 0, 3, 8, 8, 8. All right, 2 more classes to go. So now we're doing the 90s. All right, so we're going to have 0, 2, 4, 4. 4, 4, 6. And then for the last one, for the hundreds, we only have 1. And so we're just going to write that 0. All right, so that is a stem and leaf plot. So again, what is the stem and leaf, or sorry, the stem plot or the stem and leaf graph? So the stem and leaf graph tells us about distribution. So here we saw that we had a lot of scores in the 60s, 80s, and 90s. It also tells us about whether or not we have any outliers. So outliers are things that just fall completely outside what we would expect as a pattern. For us, it looks pretty natural, right? Like, so if you think about scores on an exam, it's pretty common. You're going to have a couple of really low scores. You're going to have a couple really high scores, but most of your scores are going to fall right here in the middle. So I don't really see any outliers here. Let's look at this other example. So in this example, the data is a little bit different because the data goes to the 10th place. So for us, if let's say we had 5.5, let me make that a little bit different. Let's say we had 5.6. So the 5 is going to be your stem, and the 6 is going to be your leaf. And so I'm not going to write 0.6, I'm just going to write a plain old 6. And again, this data is already sorted for us, so we can just get straight to it. So starting with the ones, I have a 1.1 and a 1.5, so that's going to give me 1. So this number here that I just wrote, this represents 1.1. When I write the 5 as well, it represents that I also have a 1.5. Next we have the 2s. So I've got a 3, a 5, and a 7. In the 3s, I've got a 2, a 3, a 3, a 5, and 8. So 2, 3, 3, 5, 8. Next we have 4s. So 0, 2, 5, 5, 7, 8. All right, and then we're at the 5s. Oops, too far. So I have a 5 and a 6 for 5.5 and 5.6. And then we have the 6s, which is going to be 6.5, so I write a 5 here, and a 6.7, so I write a 7 here. And then I have nothing, so I don't have anything with 7s, 8s, 9s, 10s, or 11s. So I'm not going to write 0. If I were to write 0, say with the 8, that would mean that I had the data point 8.0, and we don't have that. So just leave it blank if there's nothing there to fill in. The next thing that comes up for us is going to be the 12.3. So for the 12, I'm going to write 3 to represent 12.3. And so now what I'm looking at is the data looks good. It's kind of chunked together in a natural way, you know, for the data points between 1 and 6.7. But down here at the bottom, I have this kind of like lingering weirdo, 12.3. So this is actually my outlier. Something that's not really fitting the data. It doesn't really go with the other stuff. We'll talk a little bit more about outliers kind of from a numerical perspective later, but just to get a look of it, this is what it would look like. All right, so next what we want to do is we want to do line graphs. So it's another type of graph that we use to depict data and kind of group it together. So typically what we do is we're going to put the frequency on the y-axis, right? So frequency and height. Actually, I need a little bit more space, don't I? So we're going to put our frequency here. Actually, I need to go up to 14. That's my highest frequency. So I'll do this in groups of 2. So 2, 4, 8, 10, 12, 14. 16, did I do that right? Yes. Nope. 2, 4, 6, 8, 10, 12, 14. There we go. And then the number of times in the shop. So I need to have something for 0, something for 1, something for 2, and something for 3. So this will be times in the shop. And so I'm going to have 3, 1, 2, 0. So we're so used to putting 0 right here at the origin, but we're not saying this is like a positional thing. We're just saying that we're counting the number of times or the frequency that someone had 0 repairs. All right, so what we're going to do is we're just going to go ahead and plot this. So 0 repairs, or 0 times in the shop, had frequency 7. So that's going to be right here. Then number of times or frequency that someone had to go to the shop once was 10. So that's going to go here on the 10. And then for 2 times in the shop, we had frequency that was 14. So that's going to be here. And for 3 times in the shop, that was 9. So that's going to go here. And then the way you do the line graph is you just graph all the in-betweens. You just connect the dots. Here, here, and here. So it kind of shows a trend. You do not extend the lines out in either direction. You just do it for the data that you're given. So we only have data for 0, 1, 2, 3. So we just connect the lines between 0 and 3. The last type is bar graphs. So bar graphs look a lot like histograms, which we'll see next lecture. They are not. So I just want to bring this up really briefly, actually. So bar graphs. They look like this, where there's a gap in between. Histograms look really similar, but everything is touching. So that's really the main, well, there are other differences, but just visually, that's the main difference, right? So no touching. These ones are smooshed up next to each other. All right, so let's talk about bar graphs really quick. Sometimes they're called bar charts. You'll see that in Excel, they're called bar charts, that's fine. They're just bars that are separated from each other, and they're typically rectangles, and they kind of just show, again, frequency or relative frequency. So remember that proportion, you can think of this as relative frequency. So for this example, we've got a bunch of different age groups, and we've got the number of Facebook users for each group, and then we also have the proportion of Facebook users for each group. So this example, even though we had two types of data that we could put into our bar graph, we're asked only to do age group and we're just going to do the proportion or relative frequency. We could have done it with the number of Facebook users as well, but I'm just picking one for the sake of the example. So basically what you want to do is you want to create something similar, except with rectangles. So you're going to have the age groups on the bottom. You're going to have your frequency or relative frequency as your vertical axis, and then you're going to plot. So we can go ahead and label our relative frequency here. Right, so I'm really talking about percentage. So you're taking a relative frequency and you're converting it into a percentage. So remember that relative frequency is a ratio or decimal. And then the percentage is moving decimal 2 times. All right, so on the bottom, we're going to have our age groups. So we're going to have one age group, and it's going to be 13 to 25. We have another age group that is 26 to 44. And then we have our last age group, which is 45 to 64. And what we're going to do is we're going to just draw a rectangular box up to the height of the percentages. So our biggest percentage here is 45. We also have 36, so I'm going to do it in thirds of this, so 30 and 15. All right, so we have one that is 45. I'm just going to draw this straight across. Then we have another that's 36. So that's going to be roughly right here, 36. These are just guidelines so I can draw a good bar graph. And then I have another that's 19. So that's going to be about here-ish. Okay, so for 13 to 25-year-olds, they make up 45%. So the way that I'm going to draw that is I'm going to create a rectangle here, right above where I list, maybe I'll draw a little to the left, right above where I list my age range. And then I create the rectangle, and then I want to go ahead and fill it in. All right, so that's my 13 to 25. If you want to go ahead and write on top that this is 45%, that's fine. We sometimes see that. For 26 to 44, we've got 36%. So that's going to be given here by this guy. So maybe it's easier to draw a dotted line first. And then I'll just go ahead and fill it in. So now this is my rectangle here, and I need to fill it in. And notice that I've kept the gap. And then for the last group, I've got, okay, in a perfect world, these would have the same exact width, but I'm just not that good. How about like that? Maybe that's a little better. And the 45 to 64-year-old, that's going to be our 19%. So that's up to this line here. So I'm just going to see if I can do that. Freehand. So I'm going to go ahead and label these. That was 36%, and this was 19%. Right, so that's just how you create a bar chart or a bar graph. So we can try one more here as well. So notice that the groups or the categories are a little bit different. We have race and ethnicity versus here we had age groups, right? And I actually listed out what the age groups were. In this one, we're going to do it a little bit differently. Instead of writing Asian, Asian American or Pacific Islander, and then Black or African American, and then Hispanic or Latino, I'm actually just going to label them by their number. It's like a key or a legend. All right, so we have our axis set up, and we know that we're going to do student population on the left. So again, I had choices. I could have done the AP examinee population. I chose to do overall student population. It doesn't really matter. So we have student population here. There's a way that you can actually do them side by side. Like if you wanted to compare proportion, this is a very popular thing in the media, right? We want to say like, okay, for example, Black or African American, they represent 14.7% of the student population. So why do they only represent 9% of the AP, right? So all things being equal, it should be the case that Asian Americans, they should be 5% of the AP examinee population as well. But they're actually twice as likely to be an AP examinee population, right? They went from 5% of population, student population, to 10% of AP exam population. So their likelihood of taking the AP exam is a lot higher. If we look at Black or African American, we've got 14.7% of the overall student population, yet they're only 9% of the AP population. So what's the discrepancy here? So compare that then to the Hispanic or Latino. So they're actually really consistent. They're 17.6% of the overall student population, and they're 17% of the AP examined population. Anyway, something to think about next time you read media, especially like in our current climate, our current social climate. All right, so let's go ahead and do the overall student population. And then I think I want to do something. Let's see. Okay, so I'm going to go ahead and put our race or ethnicity down here at the bottom. So we have 1, that's going to represent our Asian American or Pacific Islander. We have 2, that represents our Black or African American. 3, Hispanic or Latino. 4, American Indian or Alaska Native. 5 is white. And 6 is not reported or other. So in order to do this, I need again to get the, I'm just going to record the proportion of the student population. So my highest value here is 59.2. So I think I'm going to go up to 60. Then from here, I'll just break it into half. So we're going to have 30, 45. These are all percents. Then I have 15%. Okay, so now I can go ahead. So for overall student population, let's make this one blue. So our overall student population for Asian American or Pacific Islander, that's about 5.7%. So it's roughly a third. So that'll be about right here. Then for 2, we have Black or African American, that was 14.7, and so that's really close to 15, so I'll just kind of draw a dotted line here. And again, I'm just drawing guidelines for myself that will help me draw my rectangles. For 3, Hispanic or Latino, that was 17.6, so a bit higher. For 4, American Indian or Alaska Native, I have 1.1, so that's very low, it's down here. And then for 5, white, I have very high up here. And then for 6, that was other, that was slightly higher than Alaska Native, but really not by much. Okay, so now I'm ready to go and draw the rectangle that I need. So I'm just going to draw my rectangle for 1. And remember, these are going to be spaced out. Then I have for 2 here, I should have equal width as best as you can. And then for 3, I'm here. For 4, I'm just right there. For 5, I'm here. And then for 6, like this. So I'm going to go ahead and label the top of these. So it was 5.7%, 14.7%, 17.6%, 1.1%, 59.2%, and 1.7%. So you want to go ahead and fill these in. Now I'm being lazy. I'm just going to shade them in quickly. Right, so what this does is it gives you a visual cue or visual insight into how things are distributed. You know, it's very clear to me when I see this that a vast majority, like a lot, are represented by white students. And I see that we don't have a lot of representation here with American Indian and other. So that is how to create a bar chart. If you we're given a bar chart, you might be asked to read it or interpret it in some way. And the way that you do that is you just look at it and, like, let's say they asked you what percentage of students, what percentage of the overall student population is Hispanic or Latino? So I'm like, okay, Hispanic or Latino is 3. So I go down to 3 here in my bottom part, in the category part, and I look up and I'm like, okay, it was 17.6. And then my answer is 17.6. So it goes 2 ways. I'm going to post another video of, it's not my own video, but I found a good one online of how to make a line graph and a bar chart in Excel. And so that's going to be an assignment that I'll post up on Mom. We're going to do it the same way that we did 1.2, where you upload it or send a link. This time we're going to send a link and put it in your OneNote, and then I'll grade it.